Greetings and welcome to lecture number 6 on internal flow, unit number 5. We are discussing the flow through pipe. Already we have discussed the flow through long pipeline, flow through compound pipeline, and flow through that is also called as pipes in series and pipes in parallel. These three combinations we have studied, especially while analyzing the compound pipeline. There are a lot of labor is required for making calculations. Because if the pipeline consists of maybe 7, 8 pipes of different cross sections, then it requires, in order to calculate the head loss in each sections, we have to apply the Darcy-Weisbach equation everywhere, and so a lot of labor is required for making calculations. So in order to reduce that labor of making calculation, the concept of equivalent pipe is introduced. So this equivalent pipe is generally replaces the compound pipeline. So this session, we are going to discuss this concept of equivalent pipeline. So how to determine the size of the equivalent pipeline, which gives the same amount of discharge and same frictional losses as there in the compound pipeline. So we can easily replace with the compound pipeline with the single pipe, it is called as equivalent pipe, and analyze the flow. So often the compound pipe consisting of several pipes of varying diameter and length is to be replaced by a pipe of uniform diameter. And that pipe is called as equivalent pipe. The uniform diameter of the equivalent pipe is known as equivalent diameter of the compound pipeline. And the size of the equivalent pipe may be determined as follows. As far as the compound pipeline is concerned, suppose if L1, L2, L3, etc., and D1, D2, D3, etc., are the diameters, are length and diameters of the equivalent pipe respectively. Then the total head loss in the compound pipe, neglecting the minor losses, we have this expression that is we already discussed in the previous lecture, that is head loss in compound pipeline is the summation of head losses in individual pipes, that is pipe 1, pipe 2, pipe 3, etc. And the total discharge in that case is same, because the total discharge in compound pipeline is equal to discharge through pipe 1, discharge through pipe 2, because same discharge is carried forward in compound pipeline. Now, again, according to continuity equation, we have Q is equal to A1 V1, that is equal to A2 V2, that is equal to A3 V3. Now, instead of V1, V2, V3, if we put Q by A1, Q by A2, Q by A3, and instead of A1, if we put pi by 4 d square, instead of area, we can put pi by 4 d square. Then putting this in above expression, we have F1 L1 instead of Q1, that is Q by A, so Q square upon A square. So instead of A1 square, we can write pi by 4 D1 square, bracket square, 2GD. Similarly, we can apply this for the second pipe and third pipe and so on. This is expression of HF. Now, if all the pipes made up of same material, then we can consider F1 is equal to F2 is equal to F3, that is equal to F. So instead of, this is a printing mistake, this is F2, F3. So instead of F1, F2, F3, we can call it at F. So we take common terms out of the bracket. So F1, F is common everywhere. And then Q is common, Q square. Then pi by 4 square and 2G, these are the common. So remaining is L1 into L1 divided by D1 raised to 5, L plus L2 divided by D2 raised to 5, plus L3 divided by D3 raised to 5, plus so on. So we call this equation number 1. So this is the expression of HF for compound pipeline. Now this compound pipeline is to be replaced with the equivalent pipe. Now if the D is the diameter and L is the length of the equivalent pipe, then it would carry the same discharge Q. And if the head loss due to friction in the equivalent pipe is same as that of a compound pipe, then we can have the expression that is HF is equal to FL V square by 2GD. So this compound pipeline is to be replaced by an equivalent pipe having diameter D and length L. Then, and if it carries same discharge, then the head loss to the compound pipeline is head loss due to friction in the equivalent pipeline, same as the head loss due to friction in compound pipeline. Then we can write the expression of head loss due to friction for compound pipeline, that is HF is equal to FLV square by 2G. Again, instead of V, we can put Q by A. So Q square upon A square, that is pi by 4 D square into twice GD. So F Q square upon twice G by 4 raised square into L upon D raised to 5. So we can call this equation number 2. Now in this case, both having the same head discharge and same head loss, so we can equate 1 and 2. So equating 1 and 2, we have this expression, that is L upon D raised to 5, that is equal to L1 upon D1 raised to 5 plus L2 upon D2 raised to 5 plus L3 upon D3 raised to 5 plus so on. So this equation is called as Dupit's equation, and which is used to determine the size of the equivalent pipe, because size, that is nothing but length and diameter. So if we know the lengths of the equivalent pipes, if we know the diameter, sorry, if we know the lengths of the compound, different pipes of the compound pipeline, if we know the diameters of the different pipes of the compound pipeline, then we know the right hand side, and the total length generally L1 plus L2 plus L3 etc. that is equal to the length of the equivalent. So length of the equivalent pipe, that is equal to the length of the compound pipeline. So this term, most of the cases known to us. So only unknown is D. So what should be the diameter? So once we get this particular diameter, so from this equation we can calculate diameter and use that diameter, this diameter and length, in order to calculate the head loss due to friction. So yeah, in order to calculate the total head loss, instead of making so much calculations, we can minimize these calculations by using this concept. So that is the purpose behind this introduction of the equivalent pipe. So this is about the equivalent pipe. Sometimes this derivation can be asked, derive an expression of Dupit's equation and the size of the equivalent pipe. So this formula, if you remember, it is very much if the numerical is on equivalent pipeline, you can easily apply these relations and calculate the unknown quantities, either length of the equivalent pipeline or diameter of the equivalent. So we'll see the numerical, the piping system, which consists of 3 pipes arranged in series. The lengths of the pipes are 1200 meter, 750 meter, and 600 meter. And the diameters 750, 600, and 450 respectively. Transform the system to an equivalent pipe, 450 diameter, and determine the equivalent diameter of the pipe for length, that is 2550 meter long. So there are 2 cases. If the diameter is given, then how to calculate length, and in second case we have to determine the length. So the numerical part is not that much difficult. So pipe 1, pipe 2, pipe 3, the length diameters are given. These are the diameters. Then equivalent length we can calculate in first case, because here diameter is given, that is 450 mm. So we use diameter of the equivalent pipe is D, which is given. So length we have to calculate. So length, which is in this case, that is 871.3 meter. So this is all quantities are mm. So this is 871.3 mm. It's not meter. All this length. So this is a length. So only the thing is that we have to use this equation and calculate the unknown quantity. That's it. Nothing difficult in this problem type. So in this case, the length is given. We have to calculate diameter. Our RHS side is already given. This is RHS side. So similarly, the diameter, second case, the diameter we have to calculate. Length is given. So this is given. So again, use Dupit's equation. Here, this quantity known to us, this quantity known to us. The calculation is 557 mm. Sorry, this is meter is correct, because these are the lengths. So the total 871.3 meter, that is length, and the diameter is in mm. I'm sorry, here these are the diameters. So diameter is 557.8 mm is the diameter. So if we use this diameter And length, we can calculate the later on. This information we can use for calculating the frictional loss, and then that head we can use for calculation of pumping point. So this way, most of the cases, this gives less time for calculation. So that is not an issue if there are two, three, four pipes are there. But sometimes if the pipe uh, may consist of 10, 12 different pipes of different diameter, then it becomes tedious to calculate the head loss in each pipeline. So under that circumstances, it is comparatively easy. That's it from this session. At the end of this session, you could be able to derive an expression of equivalent pipe. How to derive? It is called as Dupit's equation. And with the help of same equation, you can calculate the size of the equivalent pipes as well. That is the takeaway from this particular session. Only you have to uh, derivation part is not that much difficult. So first we have to write the expression of head loss of compound pipeline, then convert, then put, instead of V, we can put V in terms of Q, then rearranging the expression, and we can write the head loss for compound equivalent pipeline. And equating both, we can derive the Dupit's equation. Same equation, how it can be used, you will how to apply that equation for calculating the size of the equivalent pipe, that also we can. That's it from this session. Thank you very much.